Okay, let me start. Continue now. Let me continue. Now, with every connection, a session created, a process created on the server. Correct? Agree? A process is running on the server. And with every process, some memory is also allocated, called as what? A PGA. Correct? With every process, some memory called as a PGA. We have different types of environments, applications, right? You will see a different amount of load on them. Some are heavily loaded and the few very least loaded, right? That all depends type of environment. This is one type of environment, but every connection you see a process running on the server means if 100 users are connected, that means 100 server processes are running there. With each server process, some amount of PGA. Example 5 MB is nearly example allocated 5 MB per process, right? So that means 100 sessions, it is going to be 500 MB, right? So if the number of users grows, like from 100 it became 1000 users, right? And with each user nearly average 5 MB is the PGA size. That means 1000 into 5 nearly 5 GB. 5 GB nearly your PGA. That's why in the server database server components, the memory structure, the main server memory is divided into your SGA and one more is what? PGA. PGA is nothing but sum of all the sessions, right? Okay. Now here, with every connection, a process is running here. This type of architecture is called as, or before I say about it, let me first talk about two different types of main applications. One is OLTP environment. One is what? OLTP environment, right? And the another one is non-OLTP. What is first OLTP? What is an OLTP? Anyone please online? What is an OLTP?
It's online transaction processing.
Online transaction processing. Any example? Can you please elaborate or explain?
Banking one.
Huh?
Banking.
Banking. So how we defined it's an OLTP. So normally we heard and we seen or discussed, came to know banking applications are OLTPs. But how?
It's online. Whenever we are doing any transaction, it gets updated on and in a DB also, and we got the result immediately.
Correct. So any other examples like that? Okay, so let me just make it little clear. OLTP, that is the online transaction processing. You're processing your transactions online immediately. We consider those applications. Basically, applications are the OLTP, non-OLTPs, not database, right? Database need to be designed or configured to support OLTP environment. Database is a database, right? It can be used with OLTPs or non-OLTPs or any kind of environments as. Application is the one which is OLTP. What is that? Because end users are connected to application. They are not directly connected to database, right? They don't know about database even, leave it. They know only the application. Example for me, I know the bank website, the online banking site, right? I don't know what database they are using in the background. Fine. So, okay. What is an OLTP? Online transaction processing. What do you mean by that? Now, any query I submit to my application as an end user, when I submit any query to my application, the query should be processed within 7 seconds. How many? 1, 2, 3, 4, 5, 6, 7. Within 7 seconds, if your query is getting processed and you got the result, that means it is immediately processing and giving you the results. online transaction processing, OLTPs. Those applications, we can define them as OLTPs. Simple. Right? I'm just giving a request and immediately it is giving me the result. It's not saying, hey, you submitted the query, after 2 hours, you will get data, go home now. Not like that. Right? Immediately, those are all OLTP, like bankings. When I'm doing a fund transfer or doing anything or checking out anything, right? Immediately done or not? Immediately done. Banking
Online,
sites, we say. Not only that,
online.
even the ATM, yeah, even the ATM box, that is an application on the system, right? Where we select few options, next, next. Every click is a request to your application. And every click you do, next, next, entering the things, next. How much time it takes? Hardly 1 second, 2 seconds, 3 seconds. Every click. Yes or no? Right? So can I call or can I say that ATM application is also an OLTP or not? Yeah, it's an OLTP. Immediately processing. There are many more examples, man. Day to day, most of the time we deal with OLTPs only. If I go to a shopping, online shopping, that guy is going to enter, or not online, I went to a store and that guy is going to enter everything and say enter, your bill is generated immediately. Immediately done or not? OLTPs, your DMart, any retail markets you have, right? They're all OLTPs. Immediately they are doing it. Correct? Your online shopping, even your Amazon, whatever the Flipkarts, whatever we do, they're also OLTPs. When I add to the cart, it is immediately added. If I go for a checkout, next payment, also every second, every click, it is just processed within 7 seconds and got it. Yes or no? Even your email system, the free mails, like Gmail, Yahoo Mail, whatever we are using, they're also OLTP. Because if I select few mails and say delete, immediately deleted. Right? Within 7 seconds, done or not my action? Yes. So I can call my email application also an OLTP. Now this way you can just think out, make a list day to day wherever it goes. So just think out any system is running and what application, what are the application. If you keep a request immediately processed, then that is an OLTP application. Most of the time we spend our time on the OLTP applications. Got my point? Correct. OLTPs. Now, in OLTP, right, understood, every request is processed within a second and the results are given to you immediately online at upfront. Correct? In those applications, the user community, the number of users accessing is always high. How many people might be accessing, let's say SBI Bank or ICICI Bank, right? How many people, right, in Hyderabad itself are accessing the ICICI Bank online website now at a time? Thousands and more than that. Huge. How many people might be checking their Gmail at the same time? Same time. How many? Millions of them. Yes or no? How many are on the Instagram? We can't count. Yeah. At same time, right? That is called as the concurrency. Concurrent, same time the number of users. So in OLTPs, basically what happens? The user community is very high, huge. If you go to DMart, normally you see that even 20 counters that is in one store. Imagine over across Hyderabad how many stores and each count, how many counters at a time billing, so many users, right? That's all end users, right? OLTP environment, right? Huge number of users. But whatever the request that user submits, it's a very small. And that is done within a second or a fraction of a second. Right? Within a second or a fraction of a second done. I'm selecting few mails, say delete. Deleted or not? Agree, please. Now just think again, guys, here on OLTP side. OLTP. If I say, let's say I have 1,000 users, that means if I go with this concept, understanding that every connection, every user, a process running on the server, how many users are connected? Example, 1,000 users. That means how many processes running on my server? 1,000 processes will be running on the server. Agree? So many processes, right? Now, if from 1000 it becomes 10,000, you got 10,000 server processes running. Now, please understand, every process consumes some memory cycle, and also, what is this? Memory area called as PGA. The more the processes, more CPU load, CPU time, and also more memory requirement comes in. So it is going to keep a load on the system, on my server. Now, as a DBA administrator, I need to see, hey, 10,000 guys, 10,000 processes are running. Do they really require that much? Correct? All these guys, right? Every connection, a process is running. I'm going to just check out what this guy is doing. When I check, he's not there in the office. He went for a tea break. He just logged into the system and he went for a tea break. Possible or not? As normally we see in the corporates, right? Yeah. But the process is running or not? Correct? Right? Please understand. So again, if you just think out or just look at one user, example, I am the one user who connected to, let me take email system. I'm using a email Gmail. I logged into my Gmail account or Yahoo Mail account. What I do, I'm spending nearly 1 hour in a day. What I'm going to do, once I logged in, correct? I'm going to see there are a lot of junk mails first. Let me select and say delete. One request I gave it to the application and immediately deleted. How much time it took to delete? Hardly 1 second. Correct? And then I got the remaining mails. Then again I'm going to see, okay, there are few other mails. Let me select and say delete. 1 second. Again I got, there are few mails are there. Okay, one of my friends mail. Let me say I want to read it. Click, opened it in detail. So it did a select and gave you the complete detailed information about the mail. So it took around 10 minutes to read that mail. Long story he wrote. After reading, let me say reply and type a small story again, which took another 10-15 minutes for me. Correct? So at the end, I'm going to say send. So then that my mail, whatever I typed, it is going to insert into the sent box. How much time it took? Hardly 1 second. There are few mails I selected, moved into some folder. How many actions? Click, 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 click. How many actions I might be doing? Hardly 10, 20, 30. Correct? In 1 hour of time. And every request is processed in how much of time from the server application? How much time it is doing? Only 1 second it is doing. How much? Only 1 second. So in 1 hour, that is 60 minutes, right? 60 minutes, right? I sent nearly 30 request example and it took only 30 seconds to complete. What about the remaining time? How much time? 59 minutes, 30 seconds. Correct? The server process, what he's doing? Just sitting idle, waiting for your command. Correct? So nowadays in the company, man, right? If you are seen outside and every day you are going here and there talking to so many people, just sitting here talking in the company, in that cabin, going out, playing games. Your manager will call you one day. Hey man, seems like you're very free. What happened? My project is over, sir. Oh, over. Okay, come to my desk. I'll give another task to you. Yes or no? What we call utilization. A nice term is there in our field. Utilization. Resource utilization. Better utilize the resources. Whatever the time, 8 hours, give him some work and utilize the resource. Correct? Yes. So that's what here. The server process seems like running here 59 minutes nearly, right? Out of 60 minutes, 59 minutes is completely idle. Do you want him to sit idle? No. If the server process, let's say this is the server process sitting idle, I'm going to say, hey, why you are sitting idle? Do one thing. Why can't you do the work for another user request? Do for other request, other user request, do for another, do for another. Getting my point? Like this for each user, if he's spending 1 minute, so how many users it can handle easily like this? One server process up to 60 users, yes or no? up to 60 users, it can easily manage. Getting my point? Right? So by doing this, let's say make a round figure better, say 50 users. And if there are 1000 users are actually there, and for 50 users, only one server process is enough, tell me how many server processes actually I need in that case. How many? Only 20 server processes enough. These 20 server process, because each server process capable enough in handling how many user requests? 50 users request. So only 20 for all 10,000 users. Good or not? Now I have only 20 server processes running on my system. This type of architecture normally suggested for what kind of environment? OLTP environments. OLTP environment. OLTP environment. This kind of connections are called as shared server process architecture. What architecture it is? Shared server process architecture. The server processes are actually shared by multiple users. Getting my point? Now, this is another kind of architecture, the above one. These are actually what? Non-OLTP. We call them as a decision support system or data warehouse or analytics, right? Whatever it is the names, right? N number different non-OLTPs, right? For them, we have this architecture called as a dedicated server process architecture. What is this architecture called as? For what environments? Our data warehouse, our DSS, decision support systems, where a lot of reports will be running. How many people will be connected there? Very few. Is every employee authorized or allowed to run a report every day? No. Right? If you go to DMart, is every counter are they generating a report every time? No, they're simply doing OLTP part. Reporting, there's managers, supervisors, whoever it may be, they are the one who are generating the reports. How many people are there? Here, 1000 people who are working end users, hardly you might have 10, 20, 30, 40, 50. Very few users in this category. Right? Now, whatever the request they submit, they are asking you to generate a report, a huge data to process. It will take time or not. So that means for every request, my server process is very much busy in processing the query. The report might take 2 minutes, 5 minutes, 15 minutes, half an hour, 1 hour, 2 hours, 4 hours, 10 hours, 20 hours the report is running, or it could be take 1 day or 2 days even to generate the report. Huge data. Right? So server process is busy. I can't ask him to do the work from another guy. No, he's already loaded. He can't take the other users' work. So that's why what kind of architecture is used in this? Dedicated server process architectures. Models are used in non-OLTPs. Now coming to OLTP environments, what kind of architectures are suggested or suited? Shared server process architecture. Understood, please? Is that clear? Now, again, no need to go in detail about it, because I'll tell you there is a small change happened or enhancements are happened from application layer, right? That's the reason we are not using. So what happening here? I'll just give a small overview on this part, right? We're talking about what architecture? Shared server process architecture. So you got very few number of server processes who are processing the queries. Right? Now, when I say, as I draw the lines here earlier, like this user like this, it doesn't mean that this user process will be continuously connected to this server process. No, no, no. There is no direct connection between user process and no, there is no direct connection. Right? So there will be another processes in between here. We call them as dispatches. I'll just keep it only one. You can have one or multiple. We call them as what? Dispatcher process. Now dispatcher process is the one where all this request comes in. He's the guy who takes all requests. All the requests are coming to where? To dispatcher process. Agree? All the requests coming to dispatcher. Dispatcher process will have two queues. Queue, nothing but a line. Normally we see the queues, right? Many places. Okay. Normally, olden times before the theater we used to see. Now everything is book my show, right? But still, yeah, we have queues at many places, right? So like a queue, Q-U-E-U-E, queues. Now two queues are there. One is called as a request queue. One is called as a request queue, and the another is called as a response queue. Please understand fast. One is a request queue, another is a response queue. All the request whatever coming in, dispatcher job is to simply just keep it here in which queue? Request queue. It is going to just record those requests into the request queue. Now the server processes, right, whenever they are idle, they are simply going to the request queue, take that request and process. And the results, it is going to keep it where in which queue? Response queue. Getting my point? So whichever the server process idle, he will take the next request, process and keep it here. Next request, next. Like this, the requests are taken by the server processes and processed and kept in the response queue. Dispatcher will take these responses and give it back to the user. Something like when I go to a bank, right, or an agent guy, there will be an agent guy, right? You have to simply fill up and give it to them, and that guy will take a file. In normal in government offices, a attender peon we call, that guy will take the file to all the desks and he will get all the signs, and finally it comes to me. Correct? He's like a dispatcher. I'm not directly talking to that guy or manager who it may be the right authorized. So I'm just giving to a dispatcher. Dispatcher will be responsible to make it done and get it to me. Same way here. Correct? Now what happens here might be the first query I submitted here. This is the one processed by this server process. The same user submitted next second query. Second query might be the second query got processed by him. Third query he submitted. His third query might be here, right? The statement might be processed by this. So seems like one single user, multiple requests, they are getting processed by multiple server processes. Getting my point? Now, if I look at the server process, with every server process, what you have here, what you have? PGA. So now again the PGA part here, PGA part here. Now, if I start keeping, what we have in the PGA, please? What are those? Tell me fast. Session information, bind variables, cursor stack, sort area, right? Session information, bind variables, sort area, cursor stack. Session information. Now, can I keep this user's session information here? If I keep it, fine. But the second query is done by this guy. Now this process also need to keep the same session information for this user. Again, this another query is also processed by some other process, right? He also need to keep the session information. Seems like every process is maintaining this user session information. Duplication happening or not? Duplication. Wasting the memory. Why should I keep multiple copies? Duplicated. Getting the point? This user submitted three queries, three submit statements. They got processed by different. Anyone can do that one. Might be fourth query he is processing, fifth query he is processing. So because the dispatcher just keeps all those requests in the request queue, whichever server process becomes idle, he will simply take the request and process. Correct? Okay. Now we don't want this duplication. So see here, session information, bind variable, sort area, cursor stack. So what happening here? All these three. What three? Session information, bind variables, and sort area. Right? We name it or call it as a UGA. What is that? UGA. User global area. Right? What is this totally actually? PGA. Now PGA is actually consist of what is that? UGA plus what is another guy? left cursor. So yeah, PGA consists of UGA plus cursor stack. UGA is having all these components. Then now in this architecture, which architecture? Shared server process architecture. Shared server process architecture. Your PGA will contain only what? I don't want to keep all the session information bind with, those are all common kind of thing, right? No, it will keep only what? Your PGA here. PGA will contain what? Tell me please. Only cursor stack. Then what about this UGA component? Your UGA component is going to sit here into this. What is this? UGA. What is this area called as? Large pool. So your session information is here. That means this server process can access the session information or not from this common memory, common area, right? Now this server process also can access and the other server process also can access that information. Shall I continue? So in this architecture, shared server process architecture, the server process will have the server processes PGA will contain only the cursor stack and the UGA information is actually going to sit into the large pool. So I see, understand now that large pool should be configured. See, these are optional. 1, 2, 3. What large pool? The another is Java pool. One more is Streams pool. These three components are optional, not mandatory, but these are compulsory. These are optional. If you want, you can configure them. If you don't want, you can make the values as 0, 0, 0 size, right? So based on the thing. Now, when should I configure large pool here? When should I configure large pool? One. When should I configure large pool? One, when you are using shared, what is that? Server process architecture. You should configure a large pool so that in this kind of architecture, the UGA information about these processes is maintained in the large pool. If you didn't configure the large pool, you set the size as 0, there is no memory area for large pool. Then what happens in this architecture? If you don't have the large pool, then this UGA will be taking the memory area from this one. Who is this guy? What is this component?
Shared pool.
Shared pool, right? So this UGA will take memory area or the UGA will be placed inside your shared pool. I don't want that because whatever my shared pool memory area, already two brothers are already fighting. The library cache and data dictionary cache. I want more and I want more. But means it got actually divided into two, right? Now the third person UGA is coming and he is also taking the space is not good, right? So we don't want that to be disturbed. So that's why better you configure what a separate component called as large pool for your UGA. But remember, if you didn't configure, your UGA will be placed inside the, or it will take the memory from your shared. So better recommended you configure always the large pool. In what kind of architecture? Shared server process architecture. Understood this part? So I hope you understood the OLTP environment, non-OLTP, shared server process architecture, how it is, dedicated server process architecture, correct? In OLTPs, this is the method actually suggested and recommended. Where what happens? Hundreds of thousands of users requests are just processed by only few server processes in database server. By doing this way, you are better utilizing the resources of your server, your CPU, your memory, you are better utilizing, you are not wasting them. Then let me talk more about this one. As I said, what is this shared server process architecture? Most of the clients are not using. Why? I'll be telling you. So I need to clean up this area. Let me clean. We're talking about the shared server process architecture. I hope you understood the shared server process architecture, dedicated dispatchers and server processes. I'll take few examples. Let's say this is my application. This is my application server. And this is my database server. And here are the clients. Here are the clients. Or let's say, right, end users. So end users, basically, they all connected to where? Application. Okay. End users, basically, they all connected to the application like this. As the number of users came in, it is going to send the request again or connections to the database also. 20 users connected, 20 connections created on the server, database server. This is my DB part, right? And this is my application. 20 connections are created. So what kind of architecture it is now? On the database server, right? What kind of architecture we call it is? Tell me. Shared server process or what kind of? 20 requests I got, 20 users connected to applications, 20 request connections are made on database, 20 server processes I got. What kind of?
Dedicated one.
Dedicated server process architecture, right? Okay. We talked about another one now. So we got application, we got a database here, right? So n number of users connected, right? So we got here only few server processes. So all these requests are, whatever the requests are there, they are processed like this. Correct? We have very few. Many user requests are just processed by only two. What is this architecture it is? We discussed. This is our shared server process architecture. Correct? Okay. Then you need to do the configuration. But again, in both the cases, what happening? If there are 100 users are there, 100 requests are forwarded, or 100 connections are made, right? Again, same thing here, 100 requests, 100 connection requests are forwarded. The dispatcher is handling those, server processor handling that side. So the complete control is on the database server side. Simply application what? Whatever the request got it, I'm simply forwarding. Database level, we are managing by few number of server processes. Now, applications become more intelligent here, right? Intelligent here. Whatever the number of requests we got it here, right? Applications, what they are doing, they are making only few connections to my server, and all these requests are forwarded by application only through this few connections. Correct? Applications are intelligent here. Simply what they are doing, they have already pre-existing connections with the database. Any request coming in, all the hundreds of them, they are simply forwarded through these channels. Through these channels are through this pipeline. Already so two pipes are like a few pipes are established, like few connections are already established, and all these requests will go through this. So if I look at database server, what kind of connection architecture it is? Database you have only two. What is this architecture? Seems like. What is from the database server point of view, what kind of architecture? It is a dedicated one. Correct? From database point of view, it is a dedicated one, and the application is handling the complete control in forwarding the request, because applications we have a feature called as connection pooling. Connection pooling. So Nowadays, advanced applications, right, high-end applications, they all have this feature available. This feature available. What is that? Connection pooling. So the application layer itself will take care of this part. There are only few connections on database, and all the requests, hundreds and thousands of requests coming in, they're completely controlled here, and they're simply forwarded only through these few channels available. From database server point of view, what architecture we are using? Still the same dedicated server, because applications are eligible or capable enough in doing with a feature called as connection pooling. If the applications are not capable not capable enough, then DB server level you can configure what architecture? Shared server process architecture. Both of these mostly recommended for what kind of environment? OLTPs, and these are basically for what? Non-OLTP environment.